Good morning, students. So, in this video, we'll discuss about the working of universal motor, that is speed control of universal motor, right? So, it is called universal motor. I think you have not studied about universal motor. Universal motor means it works on both AC and DC. The same motor will work both on AC and DC operation, right? That is why it is called universal motor. So, now what is our aim here is to observe the speed of universal motor by triggering the thyristors at different firing angles and plot the graph alpha versus speed, right? So to observe the speed of universal motor by triggering thyristors at different firing angles and plot the graph of alpha versus speed, right? Now what are the apparatus required? So speed control of universal motor module. So this is a kit which we need, right? And we need a universal motor and we need a tachometer also. We need a tachometer to measure the speed, right? So procedure. So connections are made as shown in the circuit diagram. I'll show you the circuit diagram. Or else anyway, the procedure you'll understand when we are doing the connections, right? Procedure we'll see when we are doing the connections. Now going to the next slide. Yes. So this is the diagram for your universal motor under AC working condition, right? When we connect universal motor to AC, what are the connections? So now as you all know, this is a variac, right? This is variac, and then this is single phase transformer just for the isolation, right? And you have an MCB which is in the kit, right? And you will have a firing circuit. I mean, sorry, a track and a firing circuit, and then universal motor. Universal motor. So this will come from the kit. So this will also be in the kit, right? So you will have single phase transformer and a variac, right? So now, so this can be an auto transformer or dimmer. Here we have represented both. You can use any one also. You can directly use it by using a variac also, not a problem, right? So now this is for AC operation. As you all know, to get AC out of AC, we should use track, correct? So now, what will be the waveform for this one? If you just see, now here whatever we are giving is AC supply as input. So this will be the form of input what we give, right? Now, if we fire this at some angles like this, so now I'll just mark the zero crossings. This for track what I'm doing, right? I'll not mention the switching pulses separately. I'll just draw it here itself. So now we'll assume that we have triggered here. We have triggered the pulses here. This is alpha, right? Now if you draw the waveform, what will be the waveform now? If you draw the waveform, so the waveform will be of this kind. Now from this 0 to alpha it will be 0, and from here you will get this waveform, and again here it will be 0. So here you will get a waveform like this. correct? So this is the kind of waveform what you get for track. Now, if I increase this, now if I increase this line, that is this alpha, this point, if I move this point, if I move this side, whatever voltage I get will be less, right? So what if the voltage what I get is less, and if that less voltage is applied to universal motor, then what happens? The speed decreases. So if alpha is less, the speed will be more because the voltage will be more. If alpha is more, the speed will be less, right? So now you should know how to derive the equation or how to derive the voltage equation for this particular what to say track circuit, right? Now coming to the next one, I hope you understood the track operation here. So this is the voltage what will be applying. This is the voltage what will be applying for this universal motor. So based on this alpha, the speed changes, right? So now coming to the second one, universal motor for DC operation. Here you see that we have an SCR. Here you see we have an SCR. Now, what an SCR will do, this is just an equation, this is just a circuit diagram for a half wave converter, correct? So now what happens here, it works only in positive half cycle and negative half cycle it doesn't work. So only DC will be applied to the what to say universal motor, and this is a freewheeling diode. And you know what happens when we have RL load. This motor is nothing but it is equivalent to RL load. So you know that in one of the mode, the voltage in the inductor will be given back to the source. So instead of that, we'll be giving back through this diode, whatever we have connected here, right? So that is why you have a freewheeling diode here. You know this operation, which you have studied in second or third module, right? So this will be the diode. It will be freewheeling in one of the modes. Now, coming to the waveform, what happens here? When I give AC here, when I give AC waveform here, so this is the input what I am giving. Now, if this is the zero crossing, based on alpha, now we'll assume what is alpha now. So I'll take this as alpha approximately. Anyway, negative cycle will not be conducting, so I'm not taking any alpha there. So now when you draw the waveform, output waveform, so this is the kind of graph what you get, right? And here it will be 0, and you will not have any negative part also because you have freewheeling diode. Now again here it will be 0, right? And so what kind of waveform is this? This is nothing but whatever we have got here is DC waveform, right? So if alpha increases, what happens? This point will move this side, so we'll get less voltage. So if less voltage is applied to the motor will run at low speed, right? So if alpha is more, the speed is less, right? You have to understand that here. I think you have understood the connections now. So we'll move on to the next slide. Yes. So this is a graph. As I told you, if speed increases, the speed decreases. Sorry, if alpha increases, the speed will decrease. The speed will decrease. So for lower values of alpha, you can see that the speed is more, right? For higher values of alpha, the speed is less, right? For both, this is for both AC and DC operation. So this will be our tabular column. So just write the serial numbers 1, 2, 3 up to we need from 0 to 180 degrees. So you can go from 0, 30, 60, In the intervals of 30 degrees, you can keep on writing up to 180 degrees, right? And here, main thing is you have to note that the voltage what we apply will be directly proportional to the speed, right? So if I apply the voltage of some 50 volts, which is full voltage, right? If I apply the voltage of 50 volts, then let us assume that the speed is 1500 rpm. This is just the calculation because we don't have the real kit here. This is just the calculation. Now, when I vary alpha and if I make this to 25 volts, if I make this to 25 volts, then obviously this 1500 will be 750 rpm. 750 rpm. So since we literally cannot measure the voltage, I mean speed here, right? Because we don't have the kit. So just assume the voltage what we are giving and assume the speed what the motor can have. Based on that, with the variation of alpha, the voltage will change. So with the change in voltage, the speed will change, right? So this is what you are supposed to do. So this is like this from for up to 180 degrees. So this also for DC operation also will do it from 0 to 180 degrees at the intervals of 30 degrees each, right? And speed you have to calculate with the formula whatever you know, right? For SCR and TRIAC. I'm not going to discuss it here because you know how to calculate that, right? So now these are the equipments what we require. So this is the kit for controlling the speed of universal motor, right? And this is a tachometer. As you all know, this is used to measure the speed. And this is the universal motor, typical universal motor. The terminals are not shown here. We'll just assume the terminals, right? And this is a variac, what we use for adjusting the voltage what we apply to the kit, right? So we'll move on to the connections. So first one we'll see for AC operation, right? For AC operation, in lab you might have one more transformer here, one more transformer with primary and secondary, right? Let us not assume it here. We'll just start with the variac itself. If it is there, you can always connect it, right? So now, just one second. So we'll see what are the connections now. Yes. Now from positive, just understand the kit here. First, what we have is here, this particular part will take the input, right? So if I give the input here, if I give the input here, after switching on the MCB, I'll get the output here. This is just for controlling part, right? And here you have discrete components. We have TRIAC and we have an SCR. We have an SCR, right? And when we are using an SCR, we need a diode. So that diode also is available here. 3 diodes are there. You can use any diode, right? Now coming to this part, this is the knob where you will be changing alpha, where you will be changing alpha. And here this switch, this is a toggle switch. So since we have both is TRIAC and SCR, you have to switch the mode properly. So when you're using SCR, it should be on the top. When you're using TRIAC, it should be on the bottom, right? The mode for which you're using, right? So for AC operation, the switch should be down. For DC operation, the switch should be up, right? And this is for switching pulses on and off. So when you're using the pulses, it should be on. It should be on, right? Now, what are these two? One is for TRIAC and the other one is for SCR. These are the switching pulses. These are the switching pulses which should be connected, to either SCR or diode. SCR or TRIAC, right? So we'll see the connections now. We'll see how the connections are done. Yes. Now what we'll do is, first we need the supply for the kit. So what I'll do is positive, positive, I'll connect it to positive, right? And negative, that is the black one, So the black one, I'll connect it to the black, right? So now the kit got supply, right? But there is a control here for the MCB just for the safety. So from here again we have to connect it to the circuit. So now from here, from positive, we are doing for AC operation first. So here what I'll do is I'll just connect this particular supply to one terminals of SCR, right? Now the other terminal of SCR, the other terminal of SCR, I'll connect it to the motor positive, the motor positive, right? Now the motor negative, the motor negative, black I'll not be able to show. I'll use some yellow color here. Yes, here this negative wire. So this negative wire will come back to the source, right? So now see the connection here. From the positive of the supply it is coming to the switch, that is triac. From the triac it is going to the motor, and from the motor negative terminal it is coming back to the supply. Now for operating the switch we need we need switching pulses. So switching pulses are available here. So what we are going to do now, we are connecting the switching pulses. So I'll take one green wire. Now assuming that this is for triac, so I'll connect the switching pulses here to the green, and then one more wire black to this anode. So now I have given the switching pulses also. So switching pulses are given and the connections are made. So simple connections, right? So once you switch on here, there is a connection which is not seen. Yeah, I'll just use a yellow wire here just for your understanding. So here black wire is connected in this form. This is the this is the negative of the transformer, right? It is connected to the negative of the supply. I hope you are clear with the connections here. So we'll just go back to the circuit and see whether it is correct. So here you can see the circuit, you can see the connections here. From the transformer, one second. Yeah, from the transformer, it is going to the MCB, and from the MCB positive, it is going to the triac, and from the triac, it is going to one of the terminals of the universal motor, and from the negative terminal of the universal motor, it is coming back to the negative of the supply. This is what we exactly did. And from the firing circuit, one is positive, that is gate signal, and the negative is connected as I showed here, right? So these are the switching pulses, green one and black one. So now how to switch on how to conduct this experiment. So we'll switch on the main supply. So from the main supply, this auto transformer will be connected. So we'll switch on the switch here, right? And we should make sure that this knob is at 0. So increase the voltage. Now how to measure the voltage here? You have voltmeter here. So what we can do here is we can connect two more wires like this. So one red, that is from here I'll connect, assuming this has a voltmeter, I'll connect one wire here and one more black wire here. So this will help me to show what is the value. Now I'll keep on increasing this knob such that this voltmeter will read some 50 volts, right? 50 volts. Now that is the voltage what I have set, and I'll not change it hereafter. So I'll not change the knob again, right? I'll not change this knob again. Now what we are going to do now, since the voltage is set to 50 volts, the motor starts rotating. No, it depends on the firing angle. I'll make sure that the firing angle is at 0. So if the firing angle is at 0, the motor will rotate at maximum speed. it will rotate at maximum speed, right? So now what happens, I'll measure the speed. Now for 0, for alpha 0, I'll see what is the speed n, that is using this tachometer I'll measure the speed of the shaft, right? So I'll get what is the speed. So we'll assume that the no load speed of this, what to say, uh, motor is 1500 rpm. So now since full alpha is given, I mean no firing angle is given, so alpha is 0, so it will rotate at 1500 rpm. Now what I'll do, I'll increase alpha to 30, so the voltage decreases, the speed also will decrease. So you have to use a suitable formula which you know for this triac operation, and then you have to solve this one. So the speed will be less, so note down that speed, right? Similarly, up to 180 degrees, you have to repeat the same procedure. Then how to switch off the supply? So first what we have to do, we have to bring this to 180 or 0, that doesn't matter. And here, reduce this knob to 0, reduce this knob to 0, and then switch off the supply, right? Then we should move on to the next experiment. I hope everyone understood triac here, right? And one more important thing which I forgot to tell you is when you are doing the triac operation, here, when you are doing the triac operation here this switch has to be down because triac is downward, so this switch has to be down, so that you have to note, right? Now we'll move on to the next one, that is DC operation. Again it will be the same thing only. You just see what are the changes. Yes, now here what happens, we'll be using this SCR here, right? Now from positive of the motor, from the positive of the transformer, we'll be using, from the positive of the motor will be, sorry, auto transformer will be connecting it to the positive of the supply. Then negative of the supply will be connected here. So again same thing here. Now what we'll do here, we'll take one red wire, and connect it to this SCR, right? Now from this SCR it will go to the motor. From this SCR it will go to the motor. Now again what will happen, here we are connecting the negative of the motor, to the negative of the supply. So the circuit is closed. Please check this one. So positive to SCR, from negative, to the SCR, and the other terminal of the SCR is connected to the motor positive. So this is positive and this is negative, and the negative is coming back to the supply. Now you have to note that there is one more connection for the diode. So what we'll do, we have to connect one diode also. So now here, so what I'll do, I'll take one more wire. So this DM, I'll connect the wire like this, one here and one more here, parallel to SCR. Is it parallel to SCR? No. One second. So how it will be connected? The diode. We'll just check the connection. So here you can see that the diode is connected. The positive of the diode is connected to anode, right? And the other one to the negative part. So how we'll be doing that? This positive of DM will be connected here, right? And the negative will be connected to negative of the supply, right? Now these need switching pulses. So for switching pulses we have to take the green wire. So we'll take a green wire. So assuming that this is the switching pulses for SCR, So this green wire, I'll connect it to this green pin, and then one more black wire, from here we'll be connecting it to this one, right? So now the connections are done. So now what will happen, again switch on the supply which is connected to the what to say variac, right? Once you switch on this one, then make sure that this is 0. Now we'll slowly increase this, and before that you have to measure the voltage as I told you. Now here, whatever voltage you can connect here also, you can connect two wires here. So this will give you the voltage. So based on the voltage, like you give it as 50 volts and leave it. Then you vary this from 0 to 180 degrees. So for 0 degrees it will be 1500 rpm, and then so on. You have to just check what will be the speed. So 0 to 180 degrees. 0 to 180 degrees. So 180 degrees, the speed should be 0. The speed should be 0. So this is how you do the experiment for what to say universal motor. So what are the things you have to remember is why it is called universal motor, because universal motor can run both on AC and DC, right? So what I want you to do is, when the connections are given like this, you know how to analyze the circuit now. You know how to analyze the circuit. So this circuit, in theoretical part, if you write, this is how it will be. So you will have AC and you will have a triac here. Theoretical part, if you write this circuit, it will look like this. So we will take some resistive load itself, right? And then this will be the switching pulses. So for this one, you have to draw the waveforms like this and obtain what is the voltage equation for this waveform based with respect to alpha, right? So this will be 0, this will be alpha, this will be pi, right? So what will be the frequency of this one? It will be pi itself, and again here it will be negative part, or else you can take up to 2 pi also, right? You can take up to 2 pi also, but the period you have to take 1 by 2 pi when you are deriving, right? So now here you have to obtain what is the equation for the output voltage, right? And you have to see how it varies with respect to alpha, and then you have to do the experiment. And the same thing for DC operation also. For DC operation, how does it look? So you'll have AC supply and you will have a SCR. This is nothing but half wave rectifier. You know how to do that, right? For RL load. And then here you will have a diode. So for this one, you have to obtain what is the output voltage V, right? So when you get the equation for this output voltage V with respect to alpha, then you will be able to get the solve this experiment easily, do this experiment easily. That is the tabulation, right? I hope everyone have understood, right? So kindly write this experiment in the record. I think everyone have the manual with you, right? So please write the experiment in the manual. Whatever is there in the manual, just write it in the record and try to take some values and obtain the values for the speed. Only thing what you need is, at firing angle 0, what is the speed? So if you take this as 1500, for remaining values of alpha, you'll get what is voltage. With respect to that voltage, calculate what is the speed. That's all, right? Thank you.